Hi, and welcome to this episode of Tech Days TV for the IT professional. My name is Demir Bursnik. I'm a senior platform advisor at Microsoft Canada, and I'm going to be taking you through this particular session today on Windows Server 8 getting started, looking at the new features for HyperV, and this is part one of two because there's just so many great things to talk about with regards to Hyper-V and Windows Server 8 that we just couldn't fit into one session. So today we're going to look at really Windows Server 8 and why we believe that it is the definitive cloud operating system. And we talk about the definitive cloud operating system for your private cloud infrastructure and then extending out into the public cloud. Really are talking about the ways that Windows Server 8 and Hyper-V itself are really designed for mission critical scale up workloads. Really looking at how can we virtualize in Windows Server 8 those workloads that were typically defined as unvirtualizable. So things like large-scale SQL Server farms, large-scale SharePoint and Exchange implementations, and so on. So we'll spend some time talking about that. We'll also look at platform resiliency. One of the things that we want to make sure is that if there is a hardware anomaly, for example, things such as your hardware, for example, has an issue where maybe there's a bad chunk of memory somewhere and so on, we want to make sure that in that situation you still are allowed to continue your work, and we'll look at how Windows Server allows you to go ahead and do that. We'll spend some time looking at the great new storage features. I'll also look at, from a Hyper-V perspective, some of the new functionality that's available with regards to where you can place your virtual machine and virtual hard disks, as well as how you can very easily live migrate storage, not just the virtual machine itself, as is available today in Windows Server 2008 R2 when implementing cluster. We'll look at how you can actually live migrate virtual machine storage from one particular disk location to another, either on the same host or across the network, or potentially use things such as SMB file shares as a place to be able to store your virtual machine hard drives and files themselves. And we'll spend a little bit of time in terms of looking at the administration elements and also talking about PowerShell. I'm not going to really get into the PowerShell demo here. I'm hoping to convince some of the great MVPs out there like Sean Kearney and others to really do a session on Windows Server 8 PowerShell and the way that you can go ahead and automate administration. The nice thing to note is the Windows Server 8 PowerShell itself does have over 200 commands just for managing your virtual machines themselves, which is great. And like I said before, there's just so much to cover. So this is part one, and I'm saving some of the really cool features for part two coming up in a few weeks. So with that, let's get going. Okay, so when we talk about Windows Server 8 as the definitive platform for cloud, what are we actually talking about there? When you're looking at cloud considerations and implementing a private cloud infrastructure in your organization, what customers have told us basically is they want to be able to virtualize any single kind of workload out there. So mission critical, scale up workloads, being able to really take those large workloads and do that. And that really means that you're looking at a number of different things. How do you make sure that you allocate proper CPUs and all the cores that are required to ensure that you've got good performance? How do you take advantage of some of those higher end features like non-uniform memory addressing or NUMA that those mission critical workloads like SQL Server can fully take advantage of, but how do you do that in a virtualized environment? So important stuff there. But also, how do you ensure that from a standpoint of storage, you've got minimal costs, minimize the complexity, and ensuring you've got security of that storage data. So, if you are implementing a cluster, for example, and you've got clustered file shares, how do you ensure that they're protected should those hard drives happen to go away? Obviously, continuous availability. We want to make sure that your infrastructure is always up and running. Being able to move virtual machines without any restrictions on how you can go ahead and do that. Not necessarily requiring a cluster in order to be able to move a virtual machine from one Hyper-V node to another, but being able to do that just over physical wire with nothing else required. And I'm going to spend more time about that in the second session, but this is something that really is important to customers, because one of the things that they kept telling us is, you can implement any feature you want, but make sure that live migration always works. So we're going to spend more time on that in session 2, but I'll talk a little bit about it in this session here with regards to storage. Networking. How do you ensure that from the perspective of networking that if you are, for example, a hoster and are hosting different departments that need to be isolated from each other or different organizations, how do you deal with multi-tenancy? You're going to find more about that in the second session as well. We'll look at, IP address management, quality of service, and so on. And then obviously, how do you automate the entire process so you're not always going through and doing manual workloads but having most of the stuff done for you. So with regards to mission critical scale up workloads, what we're talking about here is scale, and very often scale is equated to having a lot of computer resources. How many virtual CPUs can a particular virtual machine have? And granted, that's one of the important factors, but really it is all about balance. Having the correct number of computer resources, so that is the number of virtual CPUs, making sure that the memory that's allocated to those virtual CPUs is handled properly, ensuring that you're not encountering things such as bad performance because of the way that your memory infrastructure is configured. So having things such as NUMA taken into account, not just at the physical layer, but also at the virtualization layer as well. Ensuring that you got great network I/O and great network balance, and you got the capability to potentially be able to take advantage of multiple NICs in a virtual machine host, and then ensuring that those are working properly, as well as storage. How do you make sure you got the best overall storage I/O and you're optimizing that and taking advantage of things such as storage area networks are required, but also local storage where it makes sense. You want to be able to maximize hardware usage. There's no point having a virtualization host running Windows Server 8 and having its utilization be at 10 or 20%. I mean, there's no real point in doing that. That's one of the reasons people are getting away from using physical machines to run workloads, is that overall the hardware utilization is not all that great. With virtualization and with private cloud, you want to make sure that you maximize that hardware usage. And also, there really should be a direct relationship in that as you increase the number of cores of a virtual machine, you really should have almost direct increase of performance of those virtual machines by simply adding more cores to them, so that you get overall better utilization if those machines do require additional CPU work resources and so on. So virtualization benefits, like I mentioned before, such as live migration, should just work. I mean, the number one thing customers have been telling us is, if whatever you got to implement within Windows Server 8 is going to break live migration, I don't want it. So no matter what the situation is, if your network card goes down, if you want to be able to move from one physical disk to another, you want to make sure that things just work. So all the capabilities are built in there to support live migration with absolutely no trade-offs whatsoever. And also, like I mentioned before, really, how do you virtualize those workloads that were considered non-virtualizable? The 32 gigabyte virtual machine or 64 gigabyte virtual machine, or 128 gig virtual machine that requires 8 cores or 16 cores or 32 cores, making sure that those all work as required, so that you've got the best overall performance and the capability to take those large-scale workloads. And if you are going to run those large-scale workloads on a virtualization platform, on HyperV, and as part of your private cloud infrastructure, things like server resiliency, uptime, and security is paramount. Because you're typically going to have these larger machines, you want to make sure that if something does go wrong, it is taken care of and that your data is always going to be secure. So taking a look at what's in Windows Server 8 HyperV that actually helps address some of this stuff. One of the things that I do want to talk about, and I've talked about before in different sessions, is NUMA, or non-uniform memory architecture. Essentially, the way that servers are built today is, unlike before, we had something called symmetric multiprocessing, where there was a single memory bus that all the CPUs shared. Today, most servers, in fact all servers that I've seen that you purchase today, do actually take the memory and bring it closer to the CPU. The problem with a single memory bus was always the fact that you couldn't actually have all the CPUs talking to the memory at the same time if they were very, very powerful, because that bus ended up becoming the backlog. However, using physical NUMA, what ends up happening is that each socket on a motherboard is associated with a certain amount of RAM, and then CPUs or cores within that particular socket have direct access to the memory that's allocated to them. And then another socket will have additional RAM, and essentially, if any one of the CPUs required more RAM than was available within its NUMA node, which is its collection of cores and memory, it would be able to get access to the memory on another NUMA node, but that particular process called the NUMA hop was actually very, very expensive. So you want to make sure that NUMA essentially allows hosts to scale up the number of cores as memory access as well, and then partitions the cores of memory into individual nodes. And allocation latency really depends upon memory location. If the memory is close to the core, you get very, very quick access. If the memory is far away and you got to do NUMA hop, that actually is a very expensive operation. So the goal there is to minimize the number of NUMA hops. Applications that are NUMA aware, such as SQL Server, for example, will take advantage of this and recognize that some of their memory is going to be on one NUMA node and a different chunk of memory on a second NUMA node, and they'll make sure to do the right things at the application level. And OSs like Windows Server 8 do in fact take advantage of it. But the problem arises when you actually have NUMA configurations that are badly set up. So here is an actual example of a really, really great NUMA allocation. So the system is balanced, so every single socket has got the equal number of DIMMs, every single core has got a certain amount of memory to be able to go ahead and access, and everything is balanced. So memory allocation, the thread allocations are within the same NUMA node, and there's memory populated in every single node. We're not actually ever crossing NUMA boundaries. This in itself is optimal, and it is a very, very good implementation at the physical level of your virtualization hosts. Now, the thing to keep in mind here is if you purchase a server from Dell or HP or any one of those hardware vendors, when you ask them to populate the RAM based upon the number of sockets that you've purchased, they're going to do it right, and you typically will end up with an optimal and a balanced infrastructure. Issues arise, however, when individuals do things such as buy a particular server that has maybe 4 sockets on it, but then they minimize the amount of RAM and then they go out and buy their own RAM because it ends up being cheaper than what you get from a vendor. And you could in fact end up getting something like this, right? Where it isn't optimal. Node 1, for example, has 4 DIMMs, Node 2 has 3 DIMMs, Node 2 has 3 DIMMs, Node 3 has 2 DIMMs, and Node 4 has none at all. The system overall is imbalanced, okay? So memory allocation and thread allocations are happening across different NUMA nodes. There's multiple NUMA hops themselves. NUMA Node 2 has an odd number of DIMMs, which is actually not a good idea. NUMA Node 3 doesn't have enough, so it keeps going to another one, and NUMA Node 4 doesn't have any at all. So that particular set of cores, that CPU, now has to go to the other nodes in order to get memory. This happens when individuals populate the RAM in a server themselves without actually going through and reading the information about how to do that properly. So, one of the things to keep in mind is if you're suffering performance issues, even today with Windows Server 2008 R2, and you haven't properly balanced your NUMA architecture, you could in fact have an issue where performance is impacted because of the way the memory is allocated. In Windows Server 8, what actually ends up happening is we have the capability to actually allocate GuestNUMA. What that essentially means is that we expose NUMA at the virtual machine level. So if I just give you an example here, I'm going to pop into my demo here on a virtual machine. So here I've got my Windows Server 8 HyperV server. I'm just going to go into HyperV Manager. There it is. And I've got this virtual machine. I've got one of them. And if I go to its settings, one of the things that you can actually see here is under the processor setting, okay, I can control things such as percentage of allocation and so on. But if I expand processor, you will find that I now have a setting under NUMA for NUMA configuration. So in this particular machine is configured with 1 CPU, 1 NUMA node, and 1 socket. So because my physical machine itself has only actually got 1 CPU and 1 socket, the maximum number of NUMA nodes that I have is 1. But if I had a 3 or 4 socket machine, I'd actually be able to see that here. This is all grayed out because this particular virtual machine is running, but this then allows me to specify the number of NUMA nodes the virtual machine can go ahead and use, and that's important for those larger scale workloads such as SQL Server and so on that are in fact NUMA aware. So we expose in Windows Server 8 the NUMA architecture at the physical hardware level, and then make that available to the virtual machines at the virtualization level within the HyperV architecture, and that allows the applications running within those virtual machines to really understand exactly what they could take advantage of from the hardware perspective. So a very, very kind of cool setup. All right, so let me go back to the slide deck itself. So again, presenting the NUMA topology within a VM is something that we do. Again, the apps and the operating system at the guest level can now make intelligent NUMA decisions so that they can in fact do the right things. And again, the NUMA nodes themselves are aligned to the host resources, and this in fact can be policy driven per host, can be done on the best effort that we can actually even force an alignment to say, this particular VM is going to use a specific set of NUMA nodes on the physical hardware itself. So, how does that actually mean with regards to our comparison to VMware and scale-up workload support? I did actually want to throw these slides in and just let you guys understand, what the difference is between what we had before and what's currently available in Windows Server 8 Beta. And again, we haven't even said what the final result's going to look like. But in Windows Server 2008 R2, the number of logical processors on a host that we supported was 64. So basically it's number of cores times number of sockets gave us the logical processors. Now it's 160. The physical memory on a host was 1 terabyte. Now it's 2 terabytes, so we doubled that. Virtual CPUs per host used to be 512. Now it's 1,024. So we doubled that. But then the real numbers, the real alignment in terms of what's changed and what's really increased is virtual CPUs per virtual machine used to be 4. Now we support the 32 virtual machines or virtual CPUs per VM, and again that's across multiple NUMA nodes. Memory per VM has gone from 64 gigs up to 1 terabyte per virtual machine. Active VMs per host has gone from 384 to 1,024, and we've now added support for GuestNUMA. And again, with regards to clustering and higher availability, the maximum nodes in 2008 R2 was 16, now it's gone to 64, and the maximum VMs per cluster has gone from 1,000 to 4,000. Now, in terms of comparison to VMware, as you can see, to get the equivalent number of scalability that we have with regards to Windows Server 8 Beta HyperV, you really have to get into the VMware vSphere 5.0 Enterprise Plus Edition, where you've got things such as 2 terabytes of physical memory on the host, 2,048 virtual CPUs per host. We do 1,024, but then virtual CPUs per VM is 32, which is the exact same as you get Enterprise Plus. But if you get ESXi, it's only 8. Memory per VM is on par. Active VM per host, we do twice the number as well. GuestNUMA was supported across, and again, maximum nodes and VMs in a cluster, we do in fact actually have a larger number supported in Windows Server 8 Beta than they do, and we haven't even finalized the spec in terms of what this is going to look like. The other element of ensuring you've got great availability and platform and ensuring your private cloud infrastructure is always going to be up and running is platform resiliency. So one of the things that we have is kind of this deep integration between the hardware and the operating system. So we're actually going to detect errors outside of program detection itself. We do have some predictive failure analysis, and with regards to predictive failure analysis, it's really, really important to be able to do that, especially with regards to memory. One of the things that ends up really being an issue is, if you do get a bad DIMM or a bad chip within a DIMM, you got to be able to handle that and ensure that if a particular virtual machine is using it, that it's being taken care of automatically as possible. So we're going to, from the operating system perspective, there's native OS handling for ECC errors. And the WIO, the Windows Hardware Error Architecture, is going to support predictive failure analysis for ECC. So if an error count for a particular page exceeds a threshold, we're going to call the system memory manager, take that particular page offline. But we can't guarantee it'll be taken offline. We're going to tell it to go ahead and take it offline. And then Windows Hardware Error Architecture is going to add that page to the persistent bad page list. We're never going to use that particular page again. What that actually means for HyperV is the operating system, so the parent partition of your HyperV host, is going to actually forward the address of the affected page to the virtualization stack. HyperV is going to take a look at its global page address list and basically figure out which VMs are affected by that particular page. if the page is found in a virtual machine, we're going to suspend that VM temporarily. We're going to allocate a new page of memory to replace the one that's actually bad, and then we're going to resume execution of the VM, and we're going to log an event. And again, VIA is going to add that page to the persistent bad page list. So the idea here is that if we do find a bad chunk of memory, before it actually becomes an issue, we're going to make sure that it's replaced at the VM level and is working properly. And what you end up getting, is a particular error message that gets logged in the Windows Event Viewer. It basically says, a particular VM was reset because a unrecoverable physical page was used by this particular virtual machine. If you still have the problem, call support. So really this lets you know that we've taken care of the fact that there was an issue with regards to physical hardware at the memory level, and we're able to go ahead and correct that and still have the VM continue to go ahead and keep on working. One of the more exciting changes in Windows Server 8 Beta really has to do with storage. The customer is telling us that to get that high performance, we want to make sure the storage costs are lower as much as possible. Disks have become cheaper over time, but it's still relatively expensive when you have to go out, for example, to a SAN vendor and get a high-end SAN to do things such as failover clustering and so on. So they're asking us to lower the cost of storage. They want to have the ease of file share while at the same time getting the performance of block type storage. So that's one of the things that is really important, is to ensure that we've got really easy configurable storage, but really performance storage at the exact same time. Also, no downtime servicing. To add a disk, remove a disk, this should be done relatively easily within the current architecture. Also, data should be secure, so whether that disk is being shared or that storage is being shared by multiple Windows machines, Windows Server 8 machines, you want to make sure that that's secure and encrypted and it still continues to go ahead and work. Also, if we are using storage arrays and SANs, how can we ensure that we've got the best overutilization of that and the best overall performance? And also, if the storage array itself's got capabilities built in, instead of having Windows do the work, why not have the storage array go ahead and perform that particular work? And also, having native access to the storage network from within a VM for things like redundant I/O and have support for multipath I/O. Also, virtual disk should be scalable, so they should actually be very large compared to what was there before, and want to be able to do some storage metering. So in Windows Server 8 Beta, what we actually have is a number of really key enhancements with regards to the capabilities that are available within HyperV. The first one among these is live storage migration. I'm going to show you that a little bit later on in terms of a demo. Okay. We've also got support now for virtual fiber channel adapters. So that essentially means that you can connect your virtual machines, to a fiber channel adapter and actually have the virtual machines themselves take advantage of fiber channel. In Windows Server 2008 R2, we supported iSCSI for shared storage. Now we're supporting virtual fiber channel or fiber channel adapters for shared storage as well within Windows Server 8. We also support you being able to take a virtual machine's data, VHD files and so on, and store those on SMB storage on SMB 2.2. Now that means that the SMB share that you're going to go ahead and store your virtual machine VHD files and other files on has to be a Windows Server 8 SMB share, because that's where SMB 2.2 is supported. But it does allow you to, for example, store your VHD files there, but also allows you, for example, to take SQL Server 2012 database files and also store them on SMB 2.2. That is also supported. We've also changed the format from VHD to VHDX, which gives you a lot larger file size. I'll talk more about that. Also the capability to do online meta operations. I've talked about storage migration, but also online backups are supported, and a lot of really cool stuff there as well. You can, for example, also do online merging of snapshots, all the stuff that you previously in Windows Server 2008 R2 potentially had to stop the VM in order to perform. Most of those operations can now be done online as opposed to having to take the VM offline to do them. So things like live VHD merge, live new parent, and a difference in this and so on. We also have native 4K disk support, so at the physical layer, we do support 4K disks natively as opposed to having them actually have to appear like 512 byte sector disks. We now support them natively as 4K disks, which is going to give a bit of better performance. For storage area arrays, we have something called offloaded data transfer ODX. So we're working with a number of the more prominent and well-known SAN vendors to make sure that they fully take advantage of this when Windows Server 8 ships. And I'll talk more about what ODX is, but it's actually a very, very cool feature that really gives you much better performance. We've also got a ability to configure storage resource pools as well that can in fact cross different machines. Starting off with VHDX, first thing to note is that in Windows Server 2008 R2, the maximum size for a VHD file was 2 terabytes, and some of our customers indicated that in fact was too small. So what VHDX allows you to do is have larger than 2 terabyte virtual hard drive files, up to 16 terabytes today. Also, overall, you get much better performance with the VHDX format, so some of the alignment issues that people experienced today will in fact not be there, and it's going to give you much better performance. But also, they are much more resilient to corruption. Although I've never actually seen this, I have heard of a customer, for example, that while they were doing a merge of VM and they had hardware failure, they actually had the VM's virtual hard drive end up becoming corrupt. It's a very, very rare occurrence, but I mean, some customers report that it actually has happened. The VHDX format is in fact resilient to corruption, so if there is a particular issue, while it's being written to, when you restart your host, that particular file will in fact be okay. Also, we can embed user-defined metadata, so you can actually have storage of information within that particular VHDX file that allows you to, for example, have historical info in the VHDX that you can go ahead and then be able to read through PowerShell and so on. And also, finally, larger block sizes to adapt to kind of the changing workload environment, so you can take full support, for example, for larger page reads and so on. Offload data transfer. Again, a very, very cool feature. Now, this does require a storage array on the back end. And really what the idea here is, the difference between what happened in Windows Server 2008 R2 and Windows Server 8 with ODX really has to do with being able to copy files. So today, if you copied a file on Windows Server 2008 R2 from one location on a storage area network to another location on a storage area network, what actually ended up happening is Windows Server 8 would do copy, write, read, write, read, write, and Windows itself would actually be responsible for the entire process. With offload data transfer, or ODX, what actually ends up happening is Windows Server 8, first of all, talks to the storage array and says, do you support ODX? If the array says, yes, we do, Windows basically goes and says, okay, fine, copy this file from location A to location B. And what ends up happening is the array comes back and says, yep, no problem, we'll get it done. And Windows itself ends up kind of coming back saying, great, I'll consider this operation done. So the array itself ends up doing the copy work. Windows comes back and gets a basically okay that this process is done. And from Windows perspective, the file is actually in the new location, and what ends up happening is we can continue to go ahead and write, and the array itself ends up taking care of the entire process. So I'll give you a quick example. To create, for example, a 2 terabyte file on a storage array would take potentially an hour or so before, whereas right now, if you were to tell a array that actually supports ODX to create a 2 terabyte file, it would come back almost instantaneously, because the array itself would actually end up doing all the work. Other thing to keep in mind is we also support thin provisioning in Windows Server 8 as well. So you can create a thin provisioned disk, and this allows you to be able to then figure out also through PowerShell and other commands whether or not a particular disk is thin provisioned. So this is great when you need to be able to determine whether or not the disk that you're looking at is thin provision or traditionally provisioned, so that way you can do appropriate things as well. And let me actually just give you an example how to create that. So I'm going to get into something called storage pools. So we'll just get right into it. Just want to get to the proper, there it is, proper demo. So this is actually my Windows Server 8 host machine. Okay. And if you look at it right now, this is the new interface itself. And on my local server, it gives me the configuration. And for file and storage services right now, if I look at my storage pools, you will see that I've actually got 3 hard disks down here, basically 1 terabyte and 2 terabyte hard drives, and I got something called a primordial storage pool. Now, primordial storage pool really is a storage space that is created whenever you install Windows Server, and it looks at all the empty hard drives that you've got and basically says, okay, all of these are now available to be in a storage pool. And you can create a storage pool from those, and then from that create a virtual hard drive and then assign volumes to it, or have them assigned for iSCSI storage and so on. So one of the things that I want to do is I actually want to create a thinly provisioned volume on this particular storage pool. So the first thing I need to do is actually create a storage pool. So I'm going to go over here and say new storage pool, click next, give it a name. So I'm going to call this thin, I'm going to call it VM thin pool, and I'm going to click next, and then I'm going to assign a couple of hard drives. I'm just going to give it the 2 terabyte and the 1 terabyte drive. And again, options here I can have as a data store, a manual, or a hot spare. I'm going to have both of these as a data store. I could make the other one a hot spare. I just don't want to at this point. I'm going to click next. I'm going to click create. And at that point in time, we've now created a storage pool that I can then go ahead and use. So I've got a 2.73 terabyte storage pool. The next thing I need to do is from that pool create a virtual hard disk that's going to be used for storage. So I click next. Okay. There's a thin pool. I'm going to call this my my thin VM pool, just thin VM VHD. Click next. I'm going to have it do mirroring. So basically what I'm telling it, based upon the storage pool data, mirror the information across the drives that happen to be there. I could also create a simple virtual hard disk which will have data striped across the physical disks, and I can also create one with parity. So this is essentially RAID 0, if you're kind of looking at the old ways, RAID 0, RAID 1, RAID 5. I'm actually going to just have the data mirrored across the different disks for a little bit of safety. Click next. Now here's the key thing. I can create a fixed size virtual hard disk that will basically take the physical storage and give me whatever size is available to me, or I can also create a thin provisioned virtual hard disk that I can then use. Now the idea of using a thin provisioned one is if I actually do end up creating something that's larger than a physical storage, I can keep track of how close I am to getting to maximum storage capacity, and then dynamically add a disk to the storage pool, which will then end up allowing me to dynamically be able to increase the size up to whatever size is specified for the thin provisioned disk. So I'm going to actually create a 5 terabyte thin provisioned pool. Click next, click create. So I've got a 2.73 terabyte storage pool, but I'm creating a 5 terabyte thin provisioned VHD, and from that I'm going to create a new volume. Okay, so I'm going to go over here and say tasks, new volume, and I'm going to use that 5 terabyte thin provisioned VHD. Click next, make it 5 terabytes. I'm going to give it a drive letter. I'm going to give it a name, call it VM thin disk. Click next. And again, I can enable data duplication on this, but I'll talk about that probably in a future session. And what I've got now is on my host, I've got a 5 terabyte disk that is actually based upon a thin provisioned VHD that is using a storage pool that's currently got 2.73 terabytes of storage. And I can go in here and I can go to Windows Explorer, for example. I can go to VM thin disk. I can create, for example, a new folder in here and call it VMs, and then with that I can potentially down the road then be able to live migrate my virtual machines to that particular location. So let's go ahead and do that. Okay? So one of the things I did want to show you was the capability for us to be able to move not just the virtual machine but also move the storage. And this is actually important because one of the things that ends up happening is at certain points in time what you're going to want to do is potentially move a VM from one physical disk to another because you started to run out of space, or you've added new storage, or whatever it actually happens to be, or you've offloaded to SMB. Like, all those are possible. In this case, I'm simply going to take a running VM that's currently up and running and move it from my C drive to my D drive that I just gone ahead and created. So the way I do that is I right click here, go to move for the VM, and then I can click next, and it gives me some options: move the virtual machine or move the virtual machine storage. I actually don't want to move the VM. I want the VM to stay in the same spot, but I do want to move the storage, and I want to make sure that while I'm moving that storage, that VM keeps on running. So let me actually just show you. This VM itself is over here. So this is the VM. It's called Win8Serve VM01. And I can go in here and kind of play with it. So I'm currently on all servers. I can look at file and storage services. So this VM is in fact running. So if I were to go back to my host, okay, to move that, you'll see that there's the VM Win8Serve VM01, which is right here. And I click next, going to move its virtual storage. I've got some options: move all the virtual machines data to a single location, move the virtual machines data to different locations. So this allows you to take different pieces of the VM's data, move it to one spot, or move only the VHD file. I'm going to say move all the data to a single location. Just move all of it, storage, the whole ball of wax. Click next. Now, before I do that, okay, I do want to go over here to settings and just show you that the location is CVM's Win8Serve VM01 VHD for the VHD file. So that's where we're going from, and we're going to move it to my D drive, the VM's folder. Select that particular folder. Click next, and click finish. Now, this process is going to take a little bit of time, right? It's going to perform the move. The way it performs the move is it copies all of the data from the C drive to the D drive. I got about 9 gigabytes of data, so that copy, depending upon the speed of my disk, is going to take a little bit of time. But the interesting thing to note is, while this copy is going on, I'm just going to let that go. Okay? The virtual machine itself is still available, and I continue to go ahead and work with it, and I'm still doing what I need to do. Go to dashboard, I can refresh to see what the error is. I got local services error. This is something that's actually stopped. I can click OK on that and just continue to go ahead, and there it is. That problem got fixed, and I'm still working with that VM while its disk is being copied. So let's just leave that and go back to the slides, and we're going to come back to it later so you can actually see what happened. So let's go over here. So again, HyperV ODX support, like I mentioned before, a secure offload data transfer for things like VHDX creation, expansion, merging, live storage migration, and so on down the line. And just one example in terms of creation of a 10 gig fixed disk. Used to take 3 minutes if you were doing that on an average desktop. For ODX, you simply tell the SAN to do that, and it's done in a sub-second. You can't even blink before it actually says that 10 gig disk is created. All right, so let's take a look at in terms of comparison between what we have today, Windows Server 8, with regards to VMware. We do have virtual fiber channel support. That is something that's available. And let me just actually quickly go back to my host to kind of show you that. So if I were to go into my virtual machine management for in HyperV for HyperV Manager, you'll see that I have Virtual SAN Manager as an option here, and I can create a new virtual fiber channel SAN. I can even specify the names themselves. So the nice thing to keep in mind is we do in fact fully support virtual fiber channel, and then in the virtual machines themselves, I can always add a virtual fiber channel adapter that particular virtual machine can then use to connect to the virtual fiber channel SAN that we've actually implemented within the Windows Server 8 host. So fully supported. All right, just going back to the slides. All right, we do support third-party multipathing I/O. Again, it's not something you get in ESXi. It is available in Enterprise Plus. It's through vStorage API for multipathing. We have native 4K disk support. VMware does not have that yet. Maximum virtual disk size, something that's really important to note this. The maximum virtual disk size that you can create using VHDX format is 64 terabytes. that is a pretty significant size for a virtual hard drive. VMware only supports 2 terabytes, but you actually can get larger disk sizes with regards to the machines or the disks used by virtual machinery in VMware, but it's got to be done through a physical disk attached to a virtual machine. In terms of maximum pass-through disk size, for us it actually really it doesn't matter. It's whatever we can do a pass-through disk on the back end. So if your SAN is bigger than 64 terabytes, it's 200 terabytes, we'll connect to that as well and have that as a pass-through disk. VMware is limited to 64 terabytes. And we do support offload data transfer, again, native within the operating system. For VMware, you need to get into that Enterprise Plus version as well. Okay, so you're building a cloud. Right. I have good processes in place of what are other safeguards can I use to protect my data. Here's the big thing, what if you are building a cloud and you want to make sure that the hard drives that you're taking advantage of that are being shared by different hosts, in fact, are properly protected? What if that machine gets decommissioned or that array gets decommissioned? How do you ensure that those hard drives are properly taken care of? I mean, there are horror stories of organizations that have gone and have great processes in place, but something went wrong, and all of a sudden their data with patient information or credit card info ends up being on eBay. So one of the things that we have is the capability to do encrypted cluster volumes. Okay? So if you are using a Windows failover cluster within Windows Server 8, you can now actually have cluster shared volumes as well as traditional failover disks on a cluster be encrypted with BitLocker and still accessible by all the nodes in that particular cluster. What that essentially means is should that physical disk actually ever get into the wrong hands or is decommissioned and so on, it really is just a bunch of gibberish. Nobody can actually read the data because the whole hard drive has in fact been encrypted. The performance overhead for this is next to nil. There really is no reason not to use it. So always use BitLocker to encrypt your hard disks that are attached to any one of your servers. Okay. And again, cluster name objects is used to lock and unlock cluster volumes. And again, it gives you physical security for deployments outside of secure data centers, typically things like branch offices and so on. And again, you could also have the volume level encryption for compliance requirements as well, so to make sure you get proper compliance handling taken care of. And again, like I said before, performance impact is less than 1%. We actually had to go in and put a new way to monitor stuff in here because it was just so low we couldn't even read it. So we say less than 1%. So overall, this is not something that you want to avoid doing. BitLocker and encrypted cluster disks are something you definitely want to do in Windows Server 8. So let's spend a little more time talking about high availability. So with regards to high availability, what customers basically saying is, we get applications in a Fibre channel SAN. We want to make sure that we can still continue to go ahead and support those, use Fibre channel. I get legacy apps, we want to run those, but even though they don't support failover clustering, how can we go ahead and do that? Virtualizations are great with being able to enable that because you can then put those on a VM, then have those legacy applications actually be easily moved on a failover cluster that way. We want redundancy everywhere, so we want to make sure that if a network card goes away, that's taken care of. If a storage adapter goes away, that's taken care of. Redundancy up and down the stack. And also some integration with storage replication as well, whether you're using storage replication at the SAN level or if you actually want to do your own and really haven't bought that particular option from your SAN vendor or aren't using a SAN, how do you make sure you've actually got replication built in? So some of the things that we have, and we're going to talk about a lot of these in the next session, is Windows NIC teaming. So one of the things that we didn't support natively within the operating system, Windows Server 2008 R2, was the capability to do NIC teaming out of the box at the OS level. So it was always something that you had to go to a hardware vendor, a network card manufacturer to actually have them provide NIC teaming within their stack, within their driver model. One of the not so nice things is if you actually did call support and had an issue and they asked you if you were doing NIC teaming, you said yes. Typically the first thing that I have you do is turn off NIC teaming so we can actually eliminate that as a possible issue for the problem. In Windows Server 8, we're not going to be doing that anymore because we'll support NIC teaming natively in the operating system, and that essentially means that if there is an issue, it's something at the OS level that we're going to have to go ahead and deal with. And in fact, our NIC teaming will support multiple manufacturers, network cards in the exact same team. So I'll talk about that again like in the next session. Also, continuously available file server storage. So one of the things we want to be able to do is ensure that you can use SMB storage for your HyperV virtual machine data files, and have that fully integrated and also continuously available, so that you have fault-tolerant SMB shares as something you can go ahead and take advantage of. Again, I'll talk more about that in the next one. Cluster shared volumes 2.0 integration with storage areas for replication. So today, if you were doing replication at the storage area network layer and using CSVs, there may have been a few issues here and there. We're going to fully support that and integrate that with the SAN vendors themselves. Guest clustering, we have Fibre channel for high availability as well. So Fibre channel now becomes something you can do guest clustering with in Windows Server 2008 R2 if you were doing guest clustering, i.e. clustering applications within virtual machines and between virtual machines. The only shared storage provider we could support was iSCSI. In Windows Server 8, we actually will support Fibre channel as well. And again, capability to do more than one live migration of live storage migration at the exact same time. In Windows Server 2008, you could do one live migration after the other. Right now, in Windows Server 8, we can do as many as the network load will actually support. So there's no limitation. Limitation really is how much bandwidth you have available, as well as a lot of failover cluster enhancements available in Windows Server 8 as well. Some of the other things to keep in mind in terms of overall size. So support for 64 nodes and 4,000 VMs in a cluster, which is 4 times what we supported in Windows Server 2008. A really, really important feature. I'm hoping to do an entire session on this down the road, or have somebody else do it as well. Cluster aware updating. So one of the nice things in Windows Server 8 that you can in fact do is you can do updating, so patching of the hosts in a cluster, all be done automatically by the operating system itself. So you can configure for a cluster to be able to say, I want to update this cluster. And what that will do is that will actually update all the nodes in that cluster serially, basically to make sure that there's no downtime. And any virtual machines you got running on those particular nodes in that cluster will get live migrated from that node to another one, and then that node is going to end up becoming drained. It'll get patched, it'll get rebooted, and then get brought back into the cluster, and then its virtual machines will get put back on that particular node, and we'll go and update the next node in the cluster. You only have to specify that you want to do this once. You say update the cluster, and Windows Server 8 does everything else. That is actually a very, very cool thing, and I'm hoping to be able to go ahead and demo that for you at some point in the future. But that is a very, very cool feature, and I've actually seen it done, and it's just wonderful to watch. As one node starts, gets updated, the next one keeps on going, and all the workloads are live migrated between the different hosts. Very, very cool. Cluster shared volumes version 2.0, a lot of enhancements there. Also, you get the capability for failover to actually specify a priority in terms of if you're going to end up having VMs move, for example, between nodes, or there's a failover issue, which ones are going to be failed in which priority. So that's something you can also specify for the cluster itself. We have anti-affinity VM rules. If certain VMs have to be kept off different hosts because they're part, for example, of a guest cluster or something along those lines, or a network load balance cluster, we now have the capability to incorporate that very, very easily within the interface. Previously in Windows Server 2008 R2, this was actually done through registry entry, so that itself was a little bit more involved, but now it's something that's available within the interface. Again, cluster-wide task scheduling, so you can schedule tasks across the entire cluster. Inbox live migration queuing, support for SMB, application monitoring, Hyper-V level, and guest clustering via Fibre channel. Just a lot of really great enhancements with regards to failover clustering. Also, with regards to Fibre channel, just going back into that, you support the 4 virtual HBAs to each virtual machine that can be assigned, and we do assign support worldwide names and their site to each VM. We don't require rezoning today, and NPIV is actually utilized to surface the VM ports on the host. NPIV is functionality that I think over the last 3 years, every single Fibre channel vendor has actually supported, so it shouldn't be too much of an issue. And again, this also does work with live migration. So, you've got NPIV ports, and really the guest clustering is there. So essentially, when you look at foundation for private cloud and redundancy and high availability, we really have complete redundancy in the box. So if you look at it from the bottom up, at the hardware fault layer, we got Windows hardware error architecture. So if anything does in fact end up happening at the hardware layer, the OS takes care of it and remaps pages for the VMs and so on, and it still allows you to keep on going. In terms of physical no redundancy, so live migration for planned downtime. So, if you do in fact have an issue, you can live migrate the VMs if you need to do patching, cluster aware patching, we'll do that for you automatically and so on. But if you have unplanned downtime, if a host does in fact go down, this is where failover clustering kicks in and the VMs get restarted on another node should their host happen to fail. Okay. In terms of I/O redundancy, so we got network load balancing and failover with Windows NIC teaming. So you have team NICs, and if a NIC goes away, that's taken care of. We got storage multipath I/O, so if one path goes away, you got another one. Multi-channel SMB, and also things like SMB load balancing, which I'll talk about more in a future session. In terms of application and service failover, non-clusterware application, you got HyperV application monitoring. We'll actually monitor the app within the VM itself. For guest cluster, iSCSI and Fibre channel, failover. For guest teaming, there's also things like SR-IOV NICs, which again I will talk about in the next session. And disaster recovery, some of the things that we have there that I haven't talked about yet is things like HyperV Replica, where you can actually replicate a virtual machine on a continuous basis from one particular host to another host, and you can do this from a primary site to a disaster recovery site and so on. It is not real time. It doesn't mean that you're going to have 100% in sync, but the idea here is you can actually have pretty close to real time. I think the default latency is about 5 minutes, but this gives you some very, very good capability to be relatively in sync with regards to your virtual machines between a primary and a disaster recovery site. And again, this is out of the box. It's included in the operating system. It's not an additional option you actually have to buy. And again, CSV 2.0 also gives you integration with storage arrays for synchronous replication. So if you do need that 100% real time, you can work with a SAN vendor, and the SAN will actually have the capability built in, and we'll take advantage of it through CSV 2.0. With regards to automation, very simple. PowerShell is the way you automate most of what you need to do with regards to Hyper-V. There are over 200 new commands in Windows Server 8 that are related to Hyper-V itself, and they're pretty straightforward in terms of the way the commands work. So create VM is create a VM is create VM. To shut down a VM is shut down VM, and so on down the line. So it's actually pretty straightforward. I'm hoping to get others, Sean Kearney or other MVPs, to do a session on PowerShell. They're more the guru than I am, but I think it's a really worthwhile thing to be able to go ahead and learn. One of the other things I do want to point out is something called Windows Server 8 Minimal Server Interface, or MinShell. One of the things that our customers have actually told me, and many IT pros that I talk to say, I love the fact that Windows Server Core has got a very, very small footprint, so that I have to do fewer patches and all that kind of stuff, and it, overall it's more performant. But at the same time, I really, I'm not a PowerShell guru, so I'm not quite sure how to go ahead and do all of the administration if all I have is a GUI. And the remote administration tools are a great example of how to go ahead and do that. But I still want to have those tools available to me if I'm actually working on the server itself. So what I actually want to show you is MinShell, and I want to show you that in a couple of different ways. So this is my full interface, and you'll note, by the way, that my move has in fact completed. And if I look at the location, you will now see that I am on the VMs. And if I were to connect to my other virtual connection, you'll note that I really have not lost my connection to my virtual machine at all. So it's kind of cool that it all does work as documented. But what I really want to show you here is this is the full GUI running on my particular machine. So I've got Explorer, I've got Internet Explorer on here as well. I got all the full GUI stuff on my host. But the reality is I probably don't want to go ahead and do that in production. I want to use a smaller version, but I still want the GUI tools. So let me flip you to my other machine, which is this one here, which is the VM itself. You'll note that the interface is pretty well the same. I've got access to all the tools. I can go down here and I can, specify things like computer management, and all that GUI tool is there. So all the tools that I use to administer my host are easily available. But I want you to take a look at when I minimize this. There's my interface. Okay? There is no IE. There is no Windows Explorer or anything else. All I've got is a command prompt, okay? And I've got my GUI tools. This is the minimal shell interface. Now you can go from full GUI to minimal shell very, very easily. And the way you do that is and back again as well, you can add the shell afterwards, is if you go to, add rules and features, because I've taken it away from here, all I have to do is go down to feature side of things and scroll down to user interface and infrastructure. So there's the graphical management tools and infrastructure, so that's the min shell piece. If I want to add the full GUI, I just simply check server graphical shell. If I want to add a Windows 8 desktop type experience, I can check this here as well. But the important thing to note here is to go from full GUI to min shell. You simply uncheck this, can actually have the wizard basically take away the necessary components and then reboot. If you want to, go down to basically nothing at all except the server core, you can uncheck even the graphical management tools. You're now down to server core. You want to have the full desktop experience, you can go ahead and add it. And you can do this through the GUI, or you can also do this through PowerShell. So it really is kind of a cool way of being able to, for example, and what I typically do is I install the full GUI when I install the operating system, configure it the way I want, and then when I'm done, I actually take away the server graphical shell, and I simply am left with the min shell, which has the graphical management tools and a command prompt, and I don't have the overhead of the rest of the GUI infrastructure. Really, really kind of great little middle ground between using server core and using a full GUI, and it does reduce that footprint, but still gives me all the functionality that I want to be able to go ahead and administer that particular server the way I'm used to. All right, so in terms of manageability, what we have with regards to 2008, 2082, and Windows Server 8 Beta, we have HyperV PowerShell and Network PowerShell and Storage PowerShell and Windows Server 8 Beta. Really didn't have that before because, again, PowerShell has evolved. You had sconfig in Server 2008 R2 to make it a little bit easier. Can you enable and disable the shell? Well, no. For 2008 and 2008 R2, it's an operating system install time option. In Windows Server 8 Beta, it is an option that you can go ahead and basically be able to add or remove as required. And again, VM Connect support for Remote FX. So the VM Connect application is that application that you use from within Hyper-V Manager to connect to a VM and actually display its screen. If you were using Remote FX before, you actually couldn't do that. You'd have to RDP into the particular virtual machine. The VM Connect application now does in fact support Remote FX, so that's an enhancement that we made in Windows Server 8 Beta. In terms of VMware, in terms of unified management, again, all of this stuff is built into the operating system. For VMware, typically it requires an additional set of products. So unified management, intelligent patching, rapid VM provisioning, hardware and software GPU support for Remote FX, which I didn't talk about, I'll talk about later. Also, Remote FX does support remote touch, so with the most recent version of the RDP client, and again, user profile and data management is there as well. So hopefully in this session, what I've actually shown you is that Windows Server 8 is in fact a definitive cloud operating system. It is designed for mission critical and scale up, and I've gone through some of the new storage options. I've showed you live storage migration is built into Windows Server 8 Beta for Hyper-V. We've talked about high availability throughout the entire stack, things like NIC teaming, MPIO for storage, and so on down the line. And again, I'm going to show you more of that coming up in the next session, in part 2 of this particular session, with regards to some of that NIC teaming elements and so on. And again, PowerShell, really to automate the entire process, is the engine for the cloud. But at the same time, MinShell is a great way to be able to reduce your footprint on your Windows Server 8 host, while at the exact same time still keeping those graphical tools around. So next steps, what you guys should do is, first of all, download Windows Server 8 Beta. If you have not yet, just do that. Go to the TechNet Download Center, or just go to Windows Server, Microsoft.com/Windows Server, and you'll be able to get access to Windows Server 8 Beta. Download it, try it, take a look at it. It is actually very, very, very cool. I encourage everybody to go ahead and do that. If you're a TechNet subscriber, it's in the TechNet downloads as well. Also, take some courses. Microsoft Virtual Academy has some Windows Server 8 Hyper-V courses that are released as well. So it's www.microsoftvirtualacademy.com. So take a look at that and make sure that you do sign up for it, take some courses, and then see where you stack against your peers. I actually was doing well before in Canada, but I'm kind of slipped down in rankings a fair bit. Download System Center 2012. Actually, it's not RC anymore. It is RTM eval that you can go ahead and take advantage of. System Center 2012 is the key set of management tools for your private cloud infrastructure. Definitely something that you want to go ahead and get familiar with. And there now is a integration component that will also let it integrate with Windows Server 8 Beta at the same time. Also, we just announced some new certifications for the private cloud, but there's some that are already still available and valid. One is the 70-659 Windows Server 2008 R2 Server Virtualization Certification and that exam. Ruth can actually tell you more on this. There's a couple of blog posts that went up recently. But the 70-659 exam right now, if you do pass it before May 31, you've got the option to receive a $75 gift card. We also will give you a free exam voucher to take the exam. And there's some study groups that are taking place right now within your city to help you pass that particular exam. Check out the Canadian IT Pro blog, blogs.technet.com/b/canitpro for details on this, or just when I get back on the line, if you want more information, I can give you the link in the chat window. With that, it's now time for Q&A. I'm going to turn it over to Ruth to help host that particular aspect of it, but I'll be online to take some of your questions as well. And thanks a lot for sticking around for this session.